Welcome back, everyone. So let's go over how to name these binary ionic compounds that contain a metal that can form more than one charge. And I know that these metals can form more than one charge because they're on the chart that's on the previous slide of metals that can form more than one charge. And hopefully maybe you've noticed that those metals are transition metals. That's pretty common with transition metals, actually. But those are the ones that you need to know for this course. Let's go ahead and go over how to name these molecules. So CuCl. If you were to get that on an exam or a quiz, you should recognize, oh, it is a binary ionic compound. It has a metal that can form more than one charge. So I can name it either using the stock or classical method. If I was going to use the stock method, so that's the one with the Roman numerals and parentheses, I need to know what that charge on Cu is. And that's going to be dictated by the charge of what it is attached to. Remembering that the charge of the overall molecule has to equal 0. So Cl, chlorine, it's in group 7. It's a -1 charge. So that means that my copper, for my overall charge of the molecule to be 0, that means the copper must be a +1 charge. So my stock name is going to be copper 1 chloride, because it's a plus, the copper is a +1. And if you have a copper that is a +1 charge, that is cuprous. So cuprous chloride. And so hopefully you can easily see that if CuCl is copper 1 chloride, that CuCl2 would be copper 2 chloride. And since copper in that case would have to be a +2, the classical name is cupric. CRS. So again, I recognize that it is a binary ionic compound that contains a metal, chromium, that can form more than one charge. It's attached to a sulfur. Sulfur is a -2. It's in group 6. And so for the charge of that overall molecule to be 0, my chromium must be a +2. So chromium 2 sulfide or chromous sulfide. So similar thought process for Cr2S3. If each sulfur is a -2, and I've got 3 of them, then the overall charge on that for that sulfur is a +6. So that means that each chromium, to give me a +6 charge, each chromium has to be a +3. So chromium 3 sulfide or chromic sulfide. Almost done. FeBr, halfway done. FeBr2, bromine, another halogen, is a -1. There's 2 of them, so that's a -2 charge. So to counteract the -2 charge, each iron must be a +2. So iron 2 bromide or ferrous bromide. And then FeBr3, same thought process. That iron is going to have to be a +3 to counteract the -3 from the Br3. So iron 3 bromide or ferric bromide. SNI2, another halogen, iodine, -1. And there's 2 of them. So that is a -2 charge. So that means my tin must be a +2. So tin 2 iodide or stannous iodide. And last but not least in this bullet list, SnO2. So in here, my tin is attached to an oxygen. Oxygen's in group 6. It has a -2 charge. There's 2 of them. So the overall charge on that part of the molecule is a -4. So to counteract that -4, my tin in this molecule must be a +4. So tin 4 oxide or stannic oxide. So as I said, the stock naming system is one that's used most commonly in labs today, in research labs and hospital labs. You will occasionally see the classical name in literature for these kinds of molecules, and in pharmaceutical uh, pamphlets. You should feel comfortable given the formula to give the name, but you should also feel comfortable going the other way around. If I give you the name of this type of molecule, you should be able to give me the balanced ionic formula. So what is the chemical formula for cobalt 3 chloride? Ooh, okay, so I know that this molecule is ionic and it has a metal with more than one charge. It's even told me the charge here in the parentheses, so I know cobalt, looking at my periodic table, cobalt is CO, and according to what I've been told in this name here, that cobalt has a +3 charge. Chloride, oh, that's the same as chlorine, the element chlorine. And I know since chlorine is in group 7, it has a -1 charge. And so now I need to take these two species, this cation, the cobalt 3+, and this anion, the chloride -1, and put them together to form a neutral molecule. So I'm going to do the little crisscross applesauce with the charges, or that the charge on one becomes the subscript of the other, and vice versa. So my final answer would be CO, no subscript 1 needed, remember, COCl subscript 3. So that would be the proper formula for that name. So in the next video, we're going to talk about one more type of ionic compound. This is ionic compounds that have polyatomic ions, and then we will move on to molecular compounds.